Hey there, pre-calc friends. Welcome back to part 2 of our quiz review video here. We were just diving into review page number 5, question number 1, and we just realized by sketching the given information that this was going to be a side angle side triangle case, which we said was law of cosines. And we also celebrated, yay, because this is not the ambiguous case, which is always going to be one triangle no matter what we do. All right, so let's go try this one out. Let's solve this triangle, all the sides and angles. This is review 5, number 1. I'm given that A is 13, C, and angle B is 20 degrees. All right, we sketched it. We already know it's going to be SAS, which is law of cosines. All right, I'll make my answer box already. And I only need to make one of them, right? Because this is not ambiguous. There's always going to be one and only one. There's never a zero triangle case, really, with law of cosines. So we are safe. Here's side A, side C, and angle B. And we need these 3 pieces. All right, as a reminder, here's one version of law of cosines formula. C squared equals A squared plus B squared. Remember we said it starts just like Pythagorean, which makes it kind of easy to memorize. And it's important to see that the starting side is always opposite of the cosine of the angle. So whichever angle you want, whichever angle you're given, you always start with the opposite side. And here we are given angle B, so why don't we use the cosines formula that starts with B squared? Because we have angle B. All right, so B squared equals, let's do the A squared plus C squared minus 2AC cosine of B. Here we go. All right, we need side B, so B squared will be A squared plus C squared minus 2, same 2 numbers, times the cosine, running out of room, apologies, of 20 degrees. Now, I love this because if you notice, everything is on the right-hand side. So it's just one variable on the left side. So you can really just plug this whole right side into your calculator if you want, and you'll get the answer right away. If I do that, I will get that this whole thing gets to be a number, but don't forget that that's always b squared. So always square root your number that you get in the calculator. And I'm going to get that b is equal to about 7.6. So I'll put that over here for b. All right, so solve that. You can just plug it right into the calculator right away. Again, just be careful. Take the square root when you're done, and b is 7.6. Awesome. All right, now let's just pick another angle to solve for. We can either solve for angle A or angle C. We mentioned in class that we actually are kind of in a law of sines case if we run to, because we have 2 angles and a side. We also have 2 sides and an angle. And actually, we have just 1 angle. We can't do law of sines that way. But if we did do law of sines, it's because you're thinking of this as an SSA case, which is bad. You don't want to do that because you might create an extra triangle, right? This is the ambiguous case. So don't use law of sines here. If you're in law of cosines, stay in law of cosines. Don't move into law of sines because you might make up another triangle that doesn't really exist. Okay, so let's stay in law of cosines, and we'll just pick an angle. I'll pick angle C. Now, if I'm going to pick angle C, I should start with the law of cosines formula that starts with side C. All right, so I'm going to say C squared equals A squared plus B squared minus 2A C cosine of angle C. Right, and the only variable we're looking for is angle C on the right side. Everything else is a number, so now we can start solving for this. But let me just show you that it's great to use this formula because there's no ambiguous case, but it is a little bit dangerous with all the terms and the algebra steps that we have going on. I'm just sort of underlining all of my terms here. Notice that last term is a big one because it has the cosine attached to it. So here's what I'm going to do. I'm going to start moving things around a little bit. I'm going to subtract the 13 squared onto the left side. I'm going to subtract the 7.6 squared onto the left side as well. And I'm still left with a negative 2 times 13 times 6 times the cosine of angle C. And just like before with law of sines, if we're trying to solve for C, we really want to solve for cosine C, get that by itself. Which means at the time, we need to really get this whole team by itself because it's all being multiplied. And I did it, that's great. But now, we need to get the cosine of C by itself. So I'm going to divide both sides by the negative 2 times 13 times 6. Okay, and that destroys this. And now you get the cosine of angle C equals 6 squared minus 13 squared minus 7.6 squared over negative 2 times 13 times 6. And this leads me to a really interesting point, folks. Because of all this crazy algebra over here, if your algebra is strong and you feel confident, then what we're doing right now is not going to bug you and you should be okay. But just in case you're worried about making little mistakes, and some of us do, it's very, very easy to make these mistakes, there's another formula you can use to get from here all the way to here in one big step. You just have to memorize it. That's if you've got room in your brain to do it. So some of us have very full brains with all these formulas, and we'd rather not memorize another formula. But if you're in the mood, this one also works as well. The cosine of angle C, cosine of angle C is a squared plus b squared minus c squared over 2ab. If you want to try that, that would work as well. Okay, so a squared plus b squared minus c squared divided by 2ab, and it would work here as well. All right, so, and I think that would work here. We did everything okay. I'm just double checking all my numbers here, folks. We got c squared, c, and that. Good. Okay, I think everything looks good. So once I plug that in, and I'm going to take the inverse here of both sides, I'll get the cos-inverse of this massive formula. Now, when you plug it in, we saw this in class a couple times, the calculator is kind of annoying, and that doesn't understand everything unless you put parentheses. So these two red parentheses on the top are really important. Surround your entire numerator with those parentheses. Surround your entire denominator with the parentheses when you plug it in, and your calculator will read it okay. All right, and if you do that right, I should get an angle C to be about 15.6 degrees if you do it right. Did you get that too? Yippee! All right, so 15.6 degrees for that. Good. All right, we got one more angle. Should we do log cosines one more time? No way. We don't have to do all that work. Why don't we just subtract B and C from 180 and we're home free. Don't do extra work if you don't have to. How about 144.4 degrees? So we basically used one law of cosines here to solve for side B. We did one law of cosines to solve for angle C, and then we just subtracted from 180 to get angle A. So we only need two iterations of law of cosines here. Let's do the geometry double checking here. Is the longest side across from the largest angle? Yep, yep. It's the smallest side, shortest side across from the smallest angle, and also yep, yep. So we did it right. So this is a SAS case, which is the law of cosines. Again, nothing ambiguous, but a little bit more steps so you can see all the work that we have to do. So just be really careful with your math. All right, that was review 5. The next two is review 6 and 7. Review 6 is another good one, but you're going to see if you map this one out and sketch it, it will be another SAS case with law of cosines, which will be just like we did in review 5. But I'd rather do review 7, because if you look at review 7, number 1, do you notice I have side A, side B, side C, this is side, side, side. And that's going to be law of cosines again, but nothing ambiguous. All right, let's try to solve this one. All right, on 7, number 1, we are given all three sides. So I want to just jump right into my box right now. I guess side A is 5, side B is 7, side C is 8. And we need all of the angles. And since I'm looking for angles, my brain's thinking, oh, I'm going to have to use inverses again. And also because this is law of cosines, or sorry, because this is SSS, I'm going to need law of cosines here to solve. So you choose. Which angle do you want to start with? I'm going to be different. I'm going to go for B. So if I want to do b and try to solve for b, I'm going to use the law of cosines formula that starts with side b. So if we want to set it up, this would be the b squared equals a squared plus c squared minus 2ac times the cosine of angle b. Or if you want to use the shortcut formula that solves everything for you, this would be cosine of angle b equals a squared plus c squared minus b squared over 2ac. Either way you can set up whichever way you like, and you have all of a, b, and c sides, so you can just plug it in. I'm going to use the shortcut way, or I'll let you try the first way and just see if you can get to where I am. But if you do it right, I should get angle b should be the cosine inverse of a squared plus c squared minus b squared all over 2ac. And that should give me angle B when I plug it in. And in fact, when I do plug it in, rounded, I get about 60 degrees if you do it right. Yippee! Let's pick another angle. I'll go for angle C this time, and we'll do the same idea. We can use the formula that starts with side C and do 8 squared equals, or C squared equals. And actually, why don't we do that? Let me go through one whole set of a law of cosines without using the shortcut here. I'll do it the long way in case you still like the long way and you just don't want to memorize a new formula, because I hear ya. Okay, I'm solving for angle C, so I'm going to use the formula that starts with C squared. Okay, here we go. C is 8, so C squared equals 8 squared plus 5 squared plus 7 squared minus 2, 5 times 7 times the cosine of angle C. All right, so I'm going to move these things over. I get 8 squared minus 5 squared minus 7 squared equals negative 2 times 5 times 7 cosine of angle C. I see all this stuff is multiplying the cosine of C, so I'm going to divide that out. And I get 8 squared minus 5 squared minus 7 squared all over negative 2 times 5 times 7 equals the cosine of C. And if I take the cos inverse of this side, I should get angle C by itself. So angle C is the cosine inverse of that whole mess that we had over here. Again, please, 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 with sugar on top. Put the whole top in a new parentheses, put the whole bottom in new parentheses, so that your calculator will be so happy. And you punch it in, and you get angle C is about 81.8 degrees. If you do it right, let's put that in. And last step, we don't have to do a law of cosines one more time, although you can if you're a glutton for punishment. I myself am not. So I'm just going to subtract a B and C from 180, and I should get 38.2. I'm going to do the check really quick. Is the longest side across from the largest angle? Yippee! Is the shortest side across from the smallest angle? Yippee! And so we're probably right. And that's our answer for a law of cosines with side, side, side. We have to solve all the angles, so your biggest thing is just remember we're going to be using inverses many times on there. All right, and the last one to talk about is the area of that triangle. Remember, we need SAS, but we know that we have SSS. So in order to do that, we have to find one angle in between. So let's just think about it visually, and I'll let you go free to try it on your own. We were given all three sides of A, B, and C, and really, if you solve for any angle here, you will get SAS. If you solve for angle C, then you've got side, angle, side. Or you can solve for angle B and get side, angle, side. Or you can solve for angle angle A and get side, angle, side. So it's really up to you. But how do you solve for that angle? Well, you're in SSS case, so you need to use law of cosines to solve for one angle, and then you'll have SAS, and you can find the area. So again, first step is use law of cosines. Here's step one. to solve for one angle, any one you want, just like we did on the previous question. And then once you have that good to go, you can do 1/2 side times the side times, now it's the sine, right? The area formula is always sine of the angle that you just found. And if you try it here, you'll see that the area is going to be about 17.3. Now, depending on what angle you solve for, if you solve for angle A, then we have that here. So whichever one you solved for in your law of cosines, those would be the ones that you would get if you solve for them, and you can plug it right into the formula. And pre-calc friends, that's it. That's everything that's going to be on the quiz for the most part. There could be a couple word problems that look just like the ones in the homework, so you can take a peek at that, but you approach it the same way. You sketch the drawing, figure out what case we've got, and that'll help you figure out which law you've got. As you practice more and more, try to write out the law of sines formula from memory, write out the law of cosines formula from memory, write out the cases when you need law of sines, the cases when you need law of cosine, and then finally, what is the triangle area formula, and what is the case for that? And once you have those memorized, I would write that down as soon as you get the quiz, so you don't have to keep it memorized in your brain during the whole quiz. I think that's everything, folks. I hope that helped, but if you have questions, you can always talk to me in class or in extra help. Have a great rest of your day, folks. See you later.